This is a coilgun. A very simple one. It is made using a non-ferromagnetic material pipe and a coil of wire. Without moving parts, can shoot everything that enter in the pipe, as long as the thing you are trying to shoot is ferromagnetic. The working principle of this little coilgun is very simple. First, you slowly charge a big capacitor. Then, connecting the capacitor to the coil, a very high current starts flowing through the wire, building up a magnetic field, and the screw near the coil starts moving toward it. When the screw is almost arrived at the center of the coil, the capacitor is almost empty, the magnetic field disappears, and the screw continues its run. And everything works fine until you try to shoot something made of plastic. A setup like this one obviously won't work with polymer materials. I need a change of strategy. And this big guy gave me an interesting idea. During a party while the subwoofer was near a table and was also working at full power, I noticed an empty plastic cup being sucked in by the air pressure because it was too close to the subwoofer. Then, a few seconds later, the cup comes out very fast. And a stupid idea appears in my mind. Speakers can be seen as coilguns for sound. Using coils and magnets, they produce air pressure, which can propel things no matter the materials they are made of. Well, now, in my case, directing using a speaker as the air compressor is not the best option. A different design is needed. So, if a speaker compresses a large amount of air using a paper cone glued to a coil, what happens if you instead stick a piston to it? Well, for sure the amount of compressed air decreases a lot, but now with the same forces we have higher pressure. Just stick a pipe to the end of the piston, let something fall at the bottom of the pipe, and enjoy your muzzle loading musket. Anyway, if your goal are only desk experiments, the coil piston pipe setup works perfectly. But in my case, I want something usable on airsoft fields. So I built the first prototype. Inside there are two coils that activate the piston. Each coil slides on a pile of 6 neodymium magnets that are around 30 mm in diameter. The two coils are connected in parallel, so a big MOSFET can activate them. The working voltage is around 80 volts and each coil requires around 120 amps. Yes, almost a total of 20 kilowatts. The only reason why this thing doesn't turn into a puddle of lava is not because it has a good efficiency, but because the coils stays on only 5 milliseconds every shot. Then there is a cooldown of at least 2 seconds, the amount of time required by the inverter to recharge the capacitor bank that power the coils. While waiting for the capacitor charging, a little motor reloads the next shot.
See you. I don't wanna hear you tonight. I don't wanna fight you. You don't wanna know if I feel alright.
The entire cycle is controlled by the control logic board made only of discrete components. Yeah, I know, using a microcontroller or an FPGA should be a lot easier, but I like building stuff with a discrete component, and I have tons of them doing nothing. So I made a logic transistor board that controls the entire working cycle. Also, the inverter is made of discrete components.
I don't wanna see you. I don't wanna fear you tonight. You don't want.
This flowchart describes the job of the main board. In a nutshell, when you press the trigger, the circuit activates the coils until a 10 milliseconds timeout. The limit switch sensor or source voltage issues, like an empty battery, turn them off. Then starting the reload motor that runs until the cylinder switch sensor stop it. Then the circuit is ready for another cycle. A little red LED tells you when the inverter has finished to charge the capacitors. If you press the reload button, only the reload cycle is started without activating the coils. It's very useful during the game to load the first shot after changing the magazine. After testing it on the field for a while, the main problems become evident. First, the energy of the shot was too low, only 0.6 joules in the best conditions, meanwhile a too low efficiency. Second, the inverter takes too long to recharge the capacitors. Third, the main part of the case is literally a gutter, very resistant but not very nice to look at. So I decided it was time for an upgrade, and I started building a second prototype.
My darling, in fire. My darling, rose in fire. You're a liar. You say, my darling, rose in fire. In fire. You say, my darling, rose in fire. You're a liar. Shivers my spine so much, so swimming in the rivers, swimming in the rivers. I'm trying to let go of what's broken. Go of what's wrong, and you wanna go. I'm feeling alone, left in the dark, contemplating about decisions. Why does no one ever see me? Did I do something wrong? Did I hurt feelings? It is hard to be found when no one's looking. I am feeling left out and I keep screaming. No one ever understands it. Feels like I became Atlantis, hidden from the world. I'm looking for a way. I'm looking for a way. Falling down deep into a lonely void and I can't get out. Hope for something magical, 'cause no one else seems to even bother. Looks like I'm on my own, facing this loneliness. It is hard to be found when no one's looking. I am feeling left out and I keep screaming. No one ever understands it. Feels like I became Atlantis, hidden from the world. I'm looking for a way.
The second prototype brings improvements to the 3-point said before. Ferromagnetic iron core and 2 groups of neodymium magnets concentrate a strong magnetic field where a single coil piston slides, achieving the 1 joule limit with only 4000 watts, instead of 20 like before. A more powerful inverter recharges the capacitor completely in 300 milliseconds instead of the previous 2 seconds. And a new full metal case makes everything more compact. It's for sure way far from perfection, but I had a lot of fun building this project, and now, after a rapid test in my garage, it's time to take it on the field.
Round and round we go, we go.
Sorry guys, for now I don't have enough time to collect a decent amount of good gameplay clips. If this video gets enough views, probably I will make another video where I show the most interesting gameplays. So for this time it's all. I hope you like this project. And to see you in the next video.